So we've been talking about slices, creating slices in Go, and we've been using a composite literal. Now the reason we call it a composite literal is because it's a composite data type, an aggregate data type, and we give it the type and then curly brackets and then we give it the values. And so we're giving it the literal values. So it's a composite data structure, an aggregate data structure, and we're giving it the literal values. So it's a composite literal. And now that's how we've been creating our slices, is a composite literal. And we're just letting letting everything happen kind of automatically for us and not trying to optimize for performance. Now there's a couple of things you could see about a slice. You could ask for its length and you could ask for its cap. And to do that, let me see if I have that in here. Length and cap, great. That's how you do it. It's just been a year since I've done this. G, and then that's the life of being a professor. Sometimes you get to teach some stuff and sometimes you don't. And it doesn't mean you get to use it every day. It's a bummer. All right, cap. So there's the length and the cap. And so I could see that this slice is a length of 4 and a capacity of 10. So it's got this slice G has a length of 4, because when we finally print this out, it's got this 4 here, but it has a capacity of 10. That's really interesting. So I could store up to 10 values into this slice, right? Well, what if I say to G is equal to append to G, and I want to append Y. I have no idea what Y is like at this point. Okay, and then I print out G again. So now my length is 15, so I have all of these things here. My length went up to 15, but my cap went up to 20. So the cap went from 10 to 20. So the way a slice is made, a slice is made up of is a data structure made up of 3 values. Length, cap, pointer to an array. So there's an array underneath a slice. You could find out the length of the slice, you could find out the capacity, and when you exceed capacity, the runtime will create a new array, copy the values from your old array and your slice pointing to it into the new array, delete the old array, right? Sends it to be garbage collected. And so a slice is a data structure pointing to an underlying array. That mystified me a little bit when I first heard it, so if you feel mystified by it, don't worry about that. But the thing that you can take away is that you can increase the performance if you kind of have an idea, or you know the exact idea of how much you're going to store in a slice. Well, make your slice to hold that much, and you do that with make, right? So here it's like I'm saying x make slice of int, length and capacity. And so let's try that. So let's do h colon equal make slice of int. Give me a length of 10 and capacity of 20, and then let's inspect that. We're going to do funct.println and length h and cap h. And then we could even for index value colon equal range h funct.println index value. Okay. So we made a slice with a length of 10 and a capacity of 20. And then when it ranges over this, look, the length, those are already initialized to the 0 value. Okay? And so those spots are all initialized. Index position 0 through 9, the first 10 positions, which is the length. And they're at 0. So that means that I could do h at index position 1 is equal to 12. Right? And then if I func.println h, I've now put a value in there. I cannot do this. Right? I don't have an index position 11 that's been initialized yet. Index out of range. Right? I can't do that. But I can do this. And now, right, it appended 1. So I can append, and when I appended 1, my length went up to 11. This one goes to 11. The other ones only went to 10. This one goes to 11. It's one more, right? If you're at 10, you have, and that's as far as it goes. You have nowhere else. But if you're 11, you could go, I'm sorry. It's an old movie. So I could append stuff all the way up, and it's not having to change my capacity. So my underlying array is the same until I append past 20. Then it's going to go to 40. My cap will go to 40. That's just, it isn't always a double, but the lower ranges it's a double. So you can also make a slice to optimize for how much you're going to store in it. Maybe you know kind of what that's going to be. Or you could just use a composite literal, and it makes it for you, and then you don't worry about it. We're talking about, really small optimizations. And we can compare that. So there's the benchmark function, which is a lot like the testing function. And, we could compare, like, how long does it take if I use just composite literal versus how long does it take if I use make. You want to try comparing it in the next video? Let's do it.